Welcome to Mysterious Mars. This is part 2 of our look at high-rise observation, ESP 0142871685, also known as boulder tracks on the slopes of Noctis Labyrinthus. In the prior episode, we focused on the boulder tracks themselves. In this episode, we're going to take a look at some other items in this observation that I found strange or otherwise of interest for one reason or another. So let's go ahead and get started by looking at a big blob. This is the blob in question. This is some kind of flow of Martian soil. It has slid down a slope from a higher region of loose Martian dirt. What's interesting about it is that it appears to have been flowing with some viscosity, which might indicate the presence of liquid water. We're going to travel around the edges of the soil mass and inspect its anatomy in more detail. In this area of the image, we can see that the soil mass has flowed across the underlying surface. It looks like there's a number of small ridges that it's overflowed and broken through. It also looks like it's very coherent. It doesn't have the appearance of loose soil. The arrow shows the direction of flow. This is the downwardmost lobe of the mass. Again, it looks like some kind of cohesive flowing material that had a liquid quality to it. Let's take a closer look at some of the ripples. Notice how well defined and rigid the ripples are. They seem very solidified, which could indicate frozen mud. Notice also, as we examine this material, that it seems relatively pristine, as it hasn't had any sand blown onto it, and it doesn't have dunes covering it, nor does it seem particularly eroded. These things suggest to me that the creation of this mass happened fairly recently, relative to the age of the underlying terrain. There's a small ridge here that had a guiding effect on the flow of this material. You can see how the material was channeled along the ridge. These are some examples of other clumps of Martian soil that's sliding down the same slope. They look considerably different than the larger soil mass. To me, they look more like sliding loose soil would look, that doesn't contain much moisture. It's also interesting that this material doesn't contain ripples, like the larger mass of material does. This wraps up our inspection of the flowing soil mass. And now we'll move on to some stranger items. This is some kind of odd formation embedded into the Martian surface that caught my eye. It has a degree of symmetry to it, although it's not perfect symmetry. In this part of the formation, there is again some symmetry, in that there seems to be double walls on both sides of the formation. I use the term walls for lack of a better term. There is a jumbled mass of material right in the middle of it. I have the sense that this formation was in a more complete state in the past, whatever exactly that might mean. We are currently viewing a highly eroded and broken down version of whatever it used to look like. There seems to be a lot of things like this on the Martian surface, in the sense that there's some sort of interesting or odd pattern embedded into the surface that appears to have been greatly eroded down from something higher above the surface in the past. You get the sense that you're seeing the outline of what was a larger formation of some kind. What I want to show next is a little more subtle than the prior things we've looked at, and we'll have several different examples of it to consider. This is the first of them. If you look closely, you may notice that there are some regions of this image that are sharp and clearly defined, while other areas are kind of murky. The murky areas appear as though you're looking through something transparent to the surface beneath. If we zoom in, we'll be able to see this difference much more clearly. This is the clear area, and this is the murky area. We'll pan along the boundary between the two areas and then over the murky area. It seems like all parts of the image should be equally clear in a local region. This isn't explained by shadowing because we have an example of a shadow area in the middle here, and the larger area doesn't look like that. Also notice the region of these small sand dunes. There seems to be a significant diffusion of the light. This was the first example of this phenomenon. Now we're going to look at another one. I think this example is even better at demonstrating the difference between the murky and clear areas. Here is the murky area in this image. Again, we'll see much better what's going on if we take a close-up tour of the boundary between the sharp and murky areas. As we pan around the boundary between these two regions, note that even though the demarcation is quite irregular, you can still clearly see the difference between the two. Here we have a very well-defined ridge between the murky areas and the non-murky areas. The murky area is clearly bounded by this ridge. We can very distinctly see the murky area versus the sharp area. The murky area looks to me like the silt-covered bottom of a pond or slow-moving stream. I'm not sure what exactly to make of these murky areas, but I'm curious to see if anyone else might have an explanation for this. In this image, we have some kind of highly reflective material embedded in the Martian surface. I get the sense from looking at this image that this area has been washed over by a flood, and we're looking at more solid material partially buried by mud from the flood. But I'm not sure if this material is in the process of being buried, or if it was buried and is in the process of being uncovered by erosive forces. I don't have any other observations to make about this particular image, other than there was something about how this material is protruding out of the ground that caught my eye. For our next image, we have a number of different interesting things going on within it. The most noticeable of which is the two large soil masses. We'll take a closer look at them in a moment. Then we also have this interesting region above the two soil masses. It's another one of those darker mercury areas that we have examined previously. Last, we'll be looking at this small channel connected to the left mass. These masses of soil don't have ripples in them like the very first mass we examined. I'm not sure what would explain the presence or absence of ripples. The dark material appears to be relatively smooth. Now we'll take a closer look at the murky area. Here again, we have a darker, less clear area versus a brighter, better defined area. There's also a fairly distinct delimiter between them. Why is there a difference between these two regions? You can tell from the general texture that they're made of the exact same kind of material. It's just the one side has a slightly darker cast. The most obvious answer is that something has deposited a light coating of the darkish soil material, and the really only two candidates for that something would be wind or water. You would think wind doing this kind of light dusting would have a much more diffuse boundary. In contrast, water tends to leave a fairly distinct boundary when it drains away or evaporates. The last item in this image I wanted to take a closer look at is this small channel. What's interesting is that we see a small tendril of the dark material flowing through the channel into a lower area adjacent to it. This has a look of a waterborne flow. I don't think dry loose material would flow so neatly through that small channel. That wraps up our examination of this image. We'll only be taking a very quick look at the next image. Note the hazy quality of the channel basin, similar to what we've seen in prior images. The sand deposits here are also rather interesting, reminiscent of sand deposits under slow-moving water. This is the last image we'll examine for this episode. I noticed these interconnected linear forms and thought them somewhat unusual. I'm not sure what they could be. They don't seem like a kind of formation ordinary rocks generally take on. We'll be seeing this kind of surface pattern again and again in various Mars images. It's actually a relatively common kind of surface formation. It presents as a somewhat grid-like, interconnected pattern of lines, and we'll be seeing much more clear examples of it in the future. That's all I have for this particular episode. As you could see, I had far more questions than answers for the items we were examining. We know there's frozen water on and below the surface of Mars in various areas. Is it possible that in certain places and at certain times, under certain conditions, that it still might be in liquid form? In some of these images, we seem to see some indications of it having been in liquid form relatively recently. If you have some insight into any of the questions I raised, please feel free to comment below. I'm hoping that people with deeper expertise will weigh in on this. In our next episode, we'll be looking at the infamous face on Mars in the Cydonia region. I'm going to present visual data of that region that's gone through my imaging processing methods and talk about whether I think there's really a face there or not. So please stay tuned for that. Thank you for watching and see you in the next episode.